Okay, so we're going to do 9.34. So we have two players A and B. Each of them is going to have two options. They either can go for start or for hair. Okay, so this is basically a start hunch game where, or another name is the game of coordination. Okay, so we know that there are two pure nest equilibria where each of them is going to go for start or each of them is going to go for hair. Okay, now 9.34 is asking you to find a Nash equilibrium in mixed strategy and calculate the probability of each outcome, and so therefore confirm that expected payoff for each of the player is equal to 2. Okay, so we do not want to find the Nash equilibrium in pure strategies. We want to find a Nash equilibrium in mixed strategies. Okay, so in order to do that, first of all, we will define P over here is a probability, okay, or I would say maybe X. Okay, it's the probability that player A is going to go for start, and so therefore 1 minus X is going to be the probability that player A is going to go for hair. Very similar, we say Y is the probability that player B is going to go for start, and 1 minus Y therefore is going to be the probability that player B is going to go for hair. Okay, so what we want to do is to find the value of X and Y, which is the value of the probability that each of the players is going to be playing each of the strategy, and that is going to comprise the mixed strategy equilibrium. Okay, so I'll say let X be the probability that player A goes for start. Okay, so therefore 1 minus X is going to be the probability that player A is going to go for hair. So very similar, we let Y be the probability that player B is going to go for start. And so therefore 1 minus Y is going to be the probability that player B is going to go for hair. Okay. Okay, so what I want to do is to find the value of X and Y. So how do we do that? So first of all, we are going to find the expected payoff for each of the player. Okay, so we're going to do with player 1 or player A first. Now, so player A can either go for start or hair. Okay, so what is going to be the expected payoff for player A if player A is going to go for start? And what is going to be the expected payoff for player A if player A decides to go for hair? Okay, now, so expected payoff. Okay, if we for start. Okay, so I would say this is B, A, okay, if it's go for start. So what is going to be the expected payout for player A? Now, as you can see over here, if player A go for start, player A can either get 5 if player B is going for start as well, or 0 if player B decides to go for hair. Okay, so there are two outcomes in which player A is going to get a different payoff. Okay, so therefore expected payoff for player A, if player A is deciding to play start, is going to be with Y probability that player B is going to play start, and in that case player A is going to get 5. Okay, and with Y 1 minus Y probability that player B is going to go for hair, and in that case player A is going to get 0. Okay, so therefore the expected payout for player A if player A is going for start is going to be the probability of y that player B is going to go for stack as well, and player A is going to get 5. And the probability of 1 minus y, player B is going to go for hair, and player A is going to get 0. Okay, so therefore the expected payoff in this case is 5y, and this will just be 0. Okay, now if player A decides to go for hair, then the expected payoff for player A is going to be, so if you're looking at the second row over here, where player A deciding to go for hair, so player A can either get 2 or 2 as well, okay, depending on what player B is doing. So with the probability of y, player B is going to choose stack, and player A is going to get 2. With the probability of 1 minus y, player B is going to go for hair, and in that case, player A is going to get 2 as well. Okay, so so the expected payout for player 2 in this case, we know that it's just going to be equal to 2. Okay, so under the probability of y, player 2 gets 2, player A gets 2, and the probability of 1 minus y, player A gets 2 as well. So if you expand these, you get 2y minus 2y disappear, and it's plus 2. Okay, so we know that the expected payout is just going to be equal to 2 because the player is getting 2 anyway. Doesn't matter what player B is going to do. Okay, so those are the expected payout for player A. Okay, now so in order for player A to play a mixed strategy, which is basically play a combination between stack and hair, then it has to be the case that the expected payoff for player A by playing stack is going to be equal to the expected payoff for player A if player A decides to go for hair. Okay. And now, obviously, as you can see, if the expected payoff for player A to go for stack is bigger than the expected payout for player A if it's going for hair, then the player A is definitely going to go for stack. Okay, and so therefore we are going to have a pure strategy equilibrium in which the player is going for sure for one strategy. So that is not going to be a mixed strategy. Okay, so I'll say another. Okay, for player A, to randomize between the two strategy or to apply a mixed strategy so that we have a mixed strategy equilibrium. Okay, because what we're trying to find is a mixed strategy equilibrium. Okay, so therefore we want each of the buyer to apply a mixed strategy. We do not want them to apply a pure strategy. Okay, so we want player A to apply a mixed strategy between stack and hair. And if we want that to be the case, then it has to be the case that the expected payout for player A by playing stack will have to be equal to the expected value for player A by playing hair. Okay. If this is not the case, then the buyer will just choose a strategy that is going to result in a higher expected payoff. And if that is the case, then we have a pure strategy. We do not have a mixed strategy. Okay, so for the mixed strategy to exist, then these two payoff will have to be the same, and so therefore the player is going to play a mixed strategy between these two strategies. Okay, so therefore 5y has to be equal to 2, and so therefore y equal to 2 on 5, which is 0.4. Okay, so we found the probability y already. Okay, so now we just have to find x. So now we're going to player B. Okay, so before we already done finding the expected payout for player A. Now we are going to find the expected payout for player B. Okay, so player B expected payoff. Okay, when it goes for stack, it's going to be equal to what? So player B, if it's going to go for stack, Now, as you can see from the table over here, that is going to be the first column over here where player B is choosing to play start. It can either get 5 if player A decide to go for start and get 0 if player A decide to go for hare. Okay, so therefore there is a probability of X that player A is going to go for start and player B is going to get 5. And there is a probability of 1 minus X that player A is going to choose go for hare and player B is going to get 0. Okay, so that is the expected payout for player B by playing start. So X probability is we'll get 5 and 1 minus X probability is we'll get 0. The expected payoff is 5 times, okay, sorry, so X probability that it will get 5 and 1 minus X probability is we'll get 0. Okay, so that is going to be equal to 5X. Okay, and expected payoff for player B by going for hare is going to be equal to BBH. And so we are looking at the second column over here where player B is choosing hare. Okay, so if player A is choosing start, player B is going to get 2. And if player A is choosing hare, player B is going to get 2 as well. Okay, so we know that the expected payoff is going to be equal to 2. All right, so X probability, player B is going to get 2, and 1 minus X probability, player 2 or player B is going to get 2 as well. So the expected payoff is just going to be equal to 2. All right, so again, we want to have a mixed strategy equilibrium, which means that we want player B to be playing a mixed strategy as well. Okay, so in order for player B to play a mixed strategy, so we do not want the player to play a pure strategy in which they are definitely going to choose one strategy. We want them to be mixing between these two strategies. Okay, so for that to be the case, then again VBS has to be equal to VBH. So we got 5X equal to 2, and so therefore X is going to be equal to 0.4. All right, so we found a probability for the mixed strategy equilibrium, and that is just going to be okay, so the mixed strategy Nash equilibrium is where each of the players is going to be playing a mixed strategy between the start and hare with the probability of 0.4. Okay, and so calculate the expected payoff for the two players. Okay, so we know that the expected payoff for two players is going to be equal to 2. Okay, so because we are equating them together, and the expected payoff is equal to 2. Okay, so we conclude that for each player, the expected payoff VA is going to be equal to V, B, and it's going to be equal to 2. Okay, so as you can see, for each of the player, the expected payoff from the two strategies are equal to each other, and so they are equal to 2. Okay, so therefore, the expected payoff for the two players are equal to 2 in the Nash equilibrium, in the mixed strategy Nash equilibrium.